We all know sunlight reaches Earth through radiation. But have you ever stopped and asked, how does that even work? Like really work? The sun is a nuclear beast. It's constantly fusing hydrogen atoms to form helium, and in the process, releasing huge amounts of energy. During this chaos, electrons get kicked around like crazy, and whenever an electron accelerates, boom, it emits electromagnetic radiation. That's right, accelerating electrons equals light show. Some electrons even get flung out of the sun entirely, part of what we call the solar wind. So yeah, the sun is constantly yeeting particles and light into space. And one part of that radiation is the electromagnetic waves, aka light and heat. But what exactly is an EM wave? Let's find out. Electromagnetic waves are how energy travels through space, including light, heat, X-rays, and more. They're made of two components, an electric field and a magnetic field. These two fields are always at right angles to each other and to the direction the wave is moving. When the electric field changes, it creates a magnetic field. And when the magnetic field changes, it creates an electric field. This self-sustaining cycle allows the wave to keep moving, even through empty space. EM waves don't need particles or a medium to travel. They can move through the vacuum of space because the changing fields carry the energy forward on their own. The wave's energy depends on its frequency. Higher frequencies mean more energy. That's why gamma rays are powerful, while radio waves are gentle. And the photon? That's the particle form of this wave, the smallest chunk of electromagnetic energy. Electromagnetic waves are made up of tiny packets of energy called photons. Photons are the fundamental units that carry electromagnetic energy. These guys have energy and momentum, but no mass or charge, making them super fast, useful, and kind of mysterious. They are a bundle of sine waves with slightly different wavelengths, even though they are completely different from mechanical waves, aka sound waves. You can think of them as multiple musical notes, blending into a single pulse of sound. EM waves are how energy from the sun reaches us, across millions of miles of apparent nothingness. People often say space is a vacuum, like it's just empty nothing, but in physics, a vacuum isn't truly empty. Even where there are no atoms, there's still energy existing. Space is filled with invisible fields, and these fields can suddenly create tiny particles out of nowhere. Things like electrons and their opposites, called positrons. These ghost particles pop in, exist for a split second, and then vanish. We call this a quantum fluctuation. Now, here's something even cooler. At certain high energy points along the electromagnetic wave, the energy can be strong enough to call those ghost particles into action. Electrons can appear where there's enough energy, kind of like the wave saying, "Hey, time to show up." And when they do, they can absorb a bit of that light, the photon, and then pass it along before vanishing again. This quick exchange lets light keep moving forward. Electrons and photons have a kind of secret handshake, a built-in connection in the laws of physics. Photons carry energy, and electrons are like energy sensors. If a photon passes by and the electron can absorb that exact amount of energy, boom, it takes it. It's not just a random snack though. Electrons can only absorb photons if the energy is just right, like fitting a key into a lock. This energy can excite the electron, make it move, or even help it appear in the first place in empty space, thanks to quantum fluctuations. So in a way, electrons care about photons, because it's in their nature, they're wired to respond to them. If all this made your brain fry, let's understand it with a super simple analogy.
Yay!
Assume space to be a football ground, and assume electrons to be football players, and the photon to be a football. Now, what happens is, players randomly appear like magic, receive the ball from a player, pass it to another player and vanish. Once photons hit Earth, they don't just stop, they interact. They slam into your skin, get absorbed by atoms, and cause those atoms to vibrate faster. That extra vibration? That's what you feel as heat. So yeah, Your sunburn is basically the result of nuclear reactions from a star 150 million kilometers away. You're welcome.
Huh?
Photons fired from the sun travel at 3 into 10 to the power 8 meters per second, and reach Earth in about 8 minutes and 20 seconds. That means when you see the sun, you're seeing it as it was over 8 minutes ago. If it disappeared right now, you wouldn't even know for 8 minutes. Spooky, right? So, is space empty? Not really. Is it weird that energy becomes particles? Helps a photon, then vanishes? Definitely. But that's the beauty of physics. It's weird, wonderful, and mysterious. So next time someone tells you space is empty, hit them with some photon facts and watch their brain glitch. If your curiosity just got a cosmic boost, smash that like button like a solar flare. Share this with your fellow science lovers and subscribe, or a ghost electron will haunt your Wi-Fi. Catch you next time, where things get even weirder. Until then, stay bright, stay curious, and remember, this is where weird meets science.